Artificial intelligence is rapidly changing the world. It is transforming industries, reshaping economies, and altering the way we live and work. From self-driving cars to virtual assistants, AI is becoming an integral part of our daily lives. These technologies are not just futuristic concepts, they are here and now, making our lives more convenient and efficient. AI is already having a major impact on our lives. In our homes, AI-powered devices help us manage our schedules, control our environments, and even entertain us. In our workplaces, AI is optimizing processes, enhancing productivity, and driving innovation. The field of AI is constantly evolving, with new breakthroughs emerging all the time. Researchers and developers are continually pushing the boundaries of what AI can do, leading to advancements that were once thought to be science fiction. One of the most exciting recent developments is the emergence of Microsoft's Phi-4, a new AI model that is poised to revolutionize the field. This model represents a significant leap forward in AI technology, offering capabilities that were previously unattainable. Phi-4 is a powerful new AI model that surpasses existing models in several key areas. It is more efficient, more affordable, and more specialized in its capabilities. This means it can perform complex tasks with greater accuracy and speed, making it a valuable tool for a wide range of applications. The specialized capabilities of Phi-4 allow it to excel in areas such as natural language processing, image recognition, and predictive analytics. These advancements open up new possibilities for innovation and problem-solving across various industries. This essay will explore the significance of Phi-4, its unique features, and its potential impact on the future of AI. We will delve into how this groundbreaking model is set to change the landscape of artificial intelligence and what it means for the future of technology and society. Artificial intelligence has been a dream of computer scientists for decades. From the early days of computing, visionaries imagined machines that could think, learn, and adapt like humans. These pioneers laid the groundwork for what would become one of the most transformative technologies of our time. Early AI systems were limited in their capabilities, often restricted to simple tasks and rule-based operations. These early models struggled with complex problems and lacked the flexibility we see in modern AI. But recent advances in computing power and machine learning have led to a surge in AI research and development. The exponential growth in data availability and the development of sophisticated algorithms have propelled AI into new realms of possibility. Today, AI is used in a wide range of applications, including image recognition, natural language processing, and robotics. These technologies are becoming integral parts of our daily lives, from the smartphones we use to the cars we drive. The rise of AI has been fueled by the development of powerful new AI models. These models are capable of performing tasks that were once thought to be the exclusive domain of human intelligence. These models are trained on massive datasets of text and code, allowing them to generate human-quality text, translate languages, and even understand and respond to complex queries. The ability to process and analyze vast amounts of data has opened up new possibilities for innovation. AI is now capable of writing different kinds of creative content, from poetry and stories to technical articles and reports. This has revolutionized fields such as journalism, content creation, and even entertainment. Some of the most well-known AI models include GPT-4 from OpenAI, which has set new standards in natural language processing and generation, and Gemini Pro from Google, which continues to push the boundaries of what AI can achieve. These advancements are just the beginning, as researchers and developers around the world continue to explore the potential of artificial intelligence. Microsoft's Phi-4 is a groundbreaking new AI model that is set to disrupt the field. Unlike its larger predecessors, Phi-4 is a small language model with 14 billion parameters. This smaller size makes Phi-4 more efficient and affordable to run, while still delivering impressive performance. Phi-4 is designed to excel in specific areas, particularly mathematical computations and complex reasoning. It leverages advanced training techniques and high-quality datasets to achieve superior performance in these domains. This specialized focus makes Phi-4 a valuable tool for researchers, engineers, and businesses looking to leverage AI for specific tasks. Phi-4's success can be attributed to several key technological advancements. These advancements have been meticulously developed and refined over years of research and innovation, setting a new benchmark in the field of artificial intelligence. One of the most important is the use of high-quality synthetic datasets in its training. These datasets are not just random collections of data, but are carefully crafted to simulate real-world scenarios and challenges. Synthetic datasets are artificially generated datasets that are designed to be more efficient and effective for training AI models. They allow researchers to create data that might be rare or difficult to obtain in the real world, thus providing a more comprehensive training ground for AI. By using synthetic datasets, Microsoft's researchers were able to train Phi-4 on a wider range of data than would have been possible with traditional datasets. This approach not only enhances the model's learning capabilities, but also ensures that it can handle a variety of tasks with greater accuracy and reliability. In addition to synthetic datasets, Phi-4 also benefits from advanced post-training techniques. These techniques are crucial for refining the model's performance and ensuring that it can adapt to new data and tasks efficiently. These techniques involve fine-tuning the model after it has been trained on a massive dataset. Fine-tuning allows the model to be adjusted and optimized for specific applications, making it more versatile and effective in real-world scenarios. This allows researchers to optimize the model for specific tasks and improve its overall performance. Whether it's natural language processing, image recognition, or predictive analytics, Phi-4 can be tailored to excel in various domains. Finally, Phi-4 leverages an optimized architecture that balances efficiency with performance. This architecture is designed to maximize computational resources while minimizing latency, ensuring that Phi-4 can deliver fast and accurate results in real-time applications. The combination of synthetic datasets, advanced post-training techniques, and an optimized architecture makes Phi-4 a groundbreaking AI model. It represents the future of artificial intelligence, where technology seamlessly integrates into our daily lives, enhancing our capabilities and transforming the way we interact with the world. Section 5. David versus Goliath. Performance benchmarks. Despite its smaller size, Phi-4 has consistently outperformed larger models like Gemini Pro and GPT-4 in specific tasks. Benchmark comparisons have shown that Phi-4 excels in mathematical problem-solving, complex reasoning, and logical thinking. These benchmarks involve testing AI models on a variety of tasks and comparing their performance. Experts in the field have been impressed by Phi-4's performance. Many believe that Phi-4's success challenges the conventional wisdom that bigger is always better in AI. Phi-4's performance suggests that smaller, more specialized models can be just as effective as larger, more general-purpose models, especially for specific tasks. Section 6. Accessibility and affordability. One of the most significant advantages of Phi-4 is its accessibility. Its smaller size and lower computational requirements make it possible to run Phi-4 on standard servers and even personal computers. This is in stark contrast to larger models that often require specialized hardware and significant resources to operate. The affordability of Phi-4 is another major advantage. Its lower computational requirements translate into lower operating costs, making it a more accessible option for businesses and researchers with limited budgets. This has the potential to democratize AI, making it accessible to a wider range of users. Section 7. Business benefits and implications. The emergence of Phi-4 has significant implications for businesses. Its affordability and specialized capabilities make it an attractive option for businesses looking to leverage AI for specific tasks. For example, businesses can use Phi-4 to automate tasks, improve decision-making, and gain a competitive edge. Phi-4's lower infrastructure and operational costs can lead to significant cost savings for businesses. Additionally, its ability to be deployed in-house enhances data security, as businesses can keep their data on their own servers. This is particularly important for businesses dealing with sensitive information. Section 8. The future of AI with PHI-4. PHI-4 represents a significant step forward in the evolution of AI. Its success demonstrates that smaller, more specialized AI models can be just as powerful and effective as larger, more general-purpose models. This has the potential to change the way AI is developed and deployed in the future. As AI continues to evolve, we can expect to see more specialized AI models like PHI-4 emerge. These models will be tailored to specific tasks and industries, providing businesses and researchers with powerful new tools to solve complex problems. Section 9. Conclusion. Microsoft's PHI-4 is a game-changer in the field of AI. Its efficiency, affordability, and specialized capabilities make it a powerful tool for businesses, researchers, and developers. As AI continues to evolve, we can expect to see more innovative models like PHI-4 emerge, further democratizing AI and unlocking its full potential.